I'm continuing to experiment and learn how to use the Triarchy vector signal generator. Will be the beginning of a third part on that. What you see on the screen is the Rigol DSA-815 spectrum analyzer with a 1.2 gigahertz AM modulated signal generated by the Triarchy. Down here on the Rigol DS4000 are the I signals. The top yellow trace is the I positive or IP signal. The blue trace is the I negative or IN signal. Down below that are the Q signals, which as you see are constants at this point. The particular experiment that I'm doing is out of the Triarchy manual on AM, and I'll go through the procedure here in a second and show you how I set this up. But basically, because this spectrum analyzer only goes to 1.5 gigahertz and the manual calls for a 1.5 gigahertz carrier, I wouldn't have been able to see the upper sideband. So I've modified this procedure only slightly. Instead of 1.5 gigahertz, I entered 1.2 gigahertz. So when we get to that point on the user interface, if you're following along in the manual, you'll see that I've made that one small change. Now I'm also planning to switch for the higher frequencies, that is above 1.5 gigahertz, to use the Instec spectrum analyzer, which will go to 3 gigahertz. But for right now, we'll stick with the Rigol. So now let's take a look at how you actually do the entry procedure. And down here are the spectra that you're supposed to be getting. What I have done is added a marker, and then at the peak, which is the carrier, and then moved that peak to the center frequency of the unit. What you can probably see over here is that it reads the center frequency as 1.2 and then 0.0000583 gigahertz. So what that tells us is that the internal clock in the Triarchy is slightly high. But that's not a serious problem, because they do provide an external clock input that you can tie to a more precise frequency standard. So if you have a rubidium standard or an accurate frequency standard in your lab of 10 megahertz, you can use that. And I'm sure if we did that, this would pull much closer to 1.2 gigahertz, which is the frequency that's entered in the interface. These are the lower and upper sidebands of the AM signal. This is a fairly clean AM modulated signal with about 80% AM modulation. So now let's take a look at the steps that are set out in the manual and how you can perform those on the screen. The first thing you have to do, of course, is to bring up the TSG software. And now, because what we're going to be working with is mostly over here to the right, I'm going to zero in on that. By the way, you should always check down here to make sure that you are connected, and we are. But we go to mode, and we want to pick single frequency without pulse mode, and it downloads that. The next thing it suggests is to input the frequency of use. You do that by clicking on frequency over here, and then they don't tell you this, but you need to click on start frequency, and you'll notice that it comes up with 1 gigahertz, which is the default setting of the unit. So we want to set this to 1.2 gigahertz. The way we do that is by just adding 1.2. And then you click here. Now you don't click enter, which is what I was trying initially, nor do you use the keyboard for your computer. You have to use this screen right up here. So we'll now click on gigahertz, and you'll notice that it sent something to the unit, and we're now at 1.2 gigahertz in frequency. The next thing we'll do is enter the amplitude here, and we want it to be 0 dBm. We click on that, and you see it says 0 dBm, and then up here where it says dBm, you click on that. Now we kept it at the default value of 0, but if you'd have entered a different value here, like -5 or +2 or something, you have to click on the dBm key over here to make that download that to the unit. So we've now set up the frequency, and remember this is a single frequency, so the start and stop frequencies are equal. We've now set the amplitude. Now we do I and Q set here, and we want to use the internal I and Q generators. Now we do analog modulation, and we're going to use the demo AM, that is demonstration amplitude modulation, and you'll notice that it switches to the display for the I and Q signals here. The next thing we want to do is enter the modulation frequency. Now this is a little bit, requires a little bit of interpretation here. The modulation frequency is actually 1/2 the I and Q count or step. In other words, there's 2 steps per hertz. So we click down here on the I and Q step count, and you'll notice it says 200. We're going to change that by adding a 0. Now you see it reads 2000, and now here we have to use the enter key. And it sends that to the unit. So we now have set up a 2000 count I and Q signal modulating a 1.2 gigahertz carrier, or in other words, a 2000 counts equals 1 kilohertz. Now I'm going to back out a little bit. And we are going to turn the RF on, which is down here in the corner, and I apologize if you can't see the mouse, but we're down here now. And we're going to turn RF on. Okay, now let's go look at the signals that are being produced. And here is the output on the Rigol spectrum analyzer, which is where we started out. So we'll now go ahead and look down at the Rigol oscilloscope at the I and Q signals. Now, of course, it's not necessary that you monitor the I and Q signals when you're doing this. It's just instructive to see that the way they generate amplitude modulation is to simply vary the in-phase modulating signal. The quadrature phase remains constant. The quadrature phase signals are down here. And also, these signals are somewhat redundant in that this one is simply the inverse of this one. This is the in-phase positive, and this is the in-phase negative signal. So I hope this is useful for those of you that might be trying to set up one of these units. And I will say that after working with this for a couple of weeks, I'm very happy with the unit and its technical performance. But the manual leaves a lot to be desired. So what I'm hoping to do with some of these videos is to clear up some of the confusion in the manual where, for example, it leaves out steps. In this last example, it leaves out the fact that the way you set the modulating frequency is by setting the I and Q count rate. It's not at all obvious. And furthermore, you have to set the rate to twice the modulating frequency. So to modulate at a kilohertz, which is what you have here, you have to set the count rate to 2000. Nothing wrong with that. It just would be nice if they would actually say that in the manual. So good unit, not so good manual. Hope you enjoy this. I will probably do some videos of some additional experiments and setups with the Triarchy because I think it's a neat unit, and I hope that you will be able to incorporate this into some of your learning about RF and modulation and various uses of vector signals. Have a nice day. See you in a future video.